Now we're going to talk about sound level expressed in decibels. In order to report intensity of sound, as you have seen in the previous examples, for example, threshold of hearing is 1 times 10 to minus 12 watts per meter square, etc. Instead of using these powers of 10, we would like to use a logarithmic scale. And basically we convert the intensities to sound levels in reference to the threshold of hearing and express them in logarithmic scale using this unit of decibel. The decibel, basically decipart, implies in tens, and bell comes from Graham Bell. Graham Bell, the person who invented telephone. Okay, so what is the definition of sound level in decibels? We use beta to indicate sound level, and sound level. The definition is the following. It is 10 logarithm I divided by I0. What is I0? I0 is 1 times 10 to minus 12 watts per meter square. It's our reference intensity. Reference intensity. It is the threshold of hearing. Threshold of hearing. So with this definition, we can write basically in decibels the threshold of hearing and the threshold of pain. For example, at 1000 Hertz frequency, we have the threshold of hearing sound level. Beta is equal to 10 log 1. It's 0 decibels. And again, in the same frequency, at the same frequency, the threshold of pain is beta 10 log 1 watts per meter square divided by 10 to minus 12. This is going to be 10 log 10 to 12. So beta is equal to 120 decibels. And usually in a work environment, earplugs are recommended for sound levels above 90 decibels. There is another way of measuring sound level that's not very scientific, it's more psychological. It's called loudness. Basically, this is a psychological response. So when you ask people on average, they report that as a rule of thumb, something sounds twice as loud if there is an increase of 10 decibels in the sound level. So 10 decibel increase in sound level, twice as loud. So it sounds twice as loud. Human ear is sensitive to sounds in the region 20 Hertz to 20 kilohertz. So that's the frequency range in which the human ear is sensitive, and it's particularly insensitive at low frequencies. So particularly insensitive at low frequencies. Now I want to take a look at an example. Let's say that we have two machines, two identical machines, and they are producing a sound intensity 2 times 10 to minus 7 watts per meter square at the point of interest. So the question is, what is the sound level of one machine? So we have for one machine, beta is equal to 10 log 2 10 to minus 7 divided by 1 10 to minus 12. So this is 10 log 2 10 to 5, and this is 53 decibels. And if we have two machines operating at the same time, two machines, identical machines operating at the same time, we would have beta is equal to 10 log, the total intensity would be 2 times I, so it's 4 times 10 to minus 7 watts per meter square. So it's 4 10 to minus 7 divided by 1 10 to minus 12. So it would be 10 log 4 10 to 5. That is 56 decibels. So doubling the intensity, causes 3 dB increase in sound level. So by the way, we're using this dB, D lowercase, B uppercase, in order to indicate decibels.